In Lesson 3-5, we will be discussing modeling with nonlinear regression. In video 3.5.1, our learning target is for students to model data using exponential, logarithmic, and logistic functions. In example 1, we will be discussing exponential regression. We are given a problem using bacteria and the growth of bacteria. The growth of a culture of bacteria is shown in the table below. Use exponential regression to model the data. Then use your model to predict how many bacteria there will be after 24 hours. Now, in our table here, it discusses the number of hours. That's our independent variable, x. And our bacteria is our dependent variable, y. The number of bacteria is dependent upon how long the bacteria has been allowed to grow. As you can see here, the bacteria is increasing over time. As time increases, our number of bacteria is increasing. Therefore, this is going to be an exponential growth equation. Now, what we're going to do, because we have several data points, we actually have 7 data points in our table. What we're going to do to find our exponential model or exponential equation, because a math model is just an equation that we can use to predict. In this case, we are going to, once we have our model, we're going to predict how many bacteria there will be after 24 hours. Okay, so what we're going to do here is we're going to go and plug this data into our lists. So for step 1, we are going to enter our data into our list, so we have to go to stat on our calculator. So looking at my calculator here, my TI-84, TI-83s and 84s are all set up pretty much the same. I want to press stat, which is right there. Okay, if I press stat on my calculator, that will bring me to the stat menu, and then step 2 would be to select edit. Okay, at the top of your screen, once you select stat, you'll be able to see the edit menu, which if you select edit, then that'll bring you to your lists. The X values or time in hours need to be entered into list 1, and your Y values or your bacteria count has to be entered into list 2. So go ahead at this point and enter the data from the table, the hours in list 1 and the bacteria in list 2. Once you have your data entered into your list, we are going to construct a scatter plot with this data. So in order to construct a scatter plot, we are going to go to our stat plot. So step 1 at this point, after we've entered our data, to construct our scatter plot, we want to go to our stat plot, which is right here under y equals, but since it's above the y equals sign, you have to press the second button first, then y equals to get to your stat plot. Once you get to your stat plot, you're going to select stat plot number 1, and you're going to go ahead under stat plot number 1, first of all, turn it on. Turn your plot on. And you're going to make sure you select the scatter plot graph. You can use your arrow keypad to highlight the scatter plot and then press enter to select it. And then you want to make sure that your data, that X list is L1 and Y list is L2, because we entered the hours into list 1 and our bacteria into list 2. Now, if you did not enter your data into list 1 and list 2, then you have to change these values to whatever list that you did enter your data into. And if you see on the calculator, right above all the numbers, here you have list 1, list 2, list 3, Under 4 is list 4. So you can go ahead and change these lists, the X list and Y list, if you entered your data into lists other than 1 and 2. At this point, we're going to go ahead and set up our window for our data here. So, now that we have our data entered and we have our stat plot turned on, we need to set up our window. Now, if you remember our data set, our X values, or the number of hours, X was between 0 and 6, and Y was between 400 and 1130. Right? All our bacteria count was between 400 and 1130, and our number of hours was between 0 and 6. So we need to choose an appropriate window. To change my window, I'm going to press the window button right here on my calculator. And when I get to the window, it's going to ask me for an X minimum. What is the lowest X value that you want? Well, if I put in 0 as my minimum, I'm going to have 0 right at this left edge of my graph. So I may want to go a little smaller than 0 to set up my window so that I can see all the data points. So I'm going to say -1 as my X minimum. X maximum, I don't want to choose 6 as my maximum because, again, 6 would be right at the right edge of our screen. So I'm going to go a little bigger than 6 and say, let's say 7. And I'll make my X scale, what each tick mark is worth on the graph, I'll make my scale 1. It seems reasonable to count by ones if I'm going from -1 to 7. My Y minimum starts at, I'm going to start a little smaller than 400, so let's just say 350. My Y maximum, I'm going to go a little bigger than 1130, so I'll say 1150. And then I'll make my Y scale count by, let's say, 50. At this point, you can go ahead and press graph, and you will see your scatter plot. Now, here they're showing a scatter plot for the data for number of hours and then the bacteria present. Notice that they made our window, or they made their window different than ours. We went from -1 to 7 up by 1, and we went from 350 to 1150 by counting by 50s. So our scatter plot might not look exactly the same as, well, it won't look exactly the same as theirs because our scale is different, but it'll look very similar. All I'm concerned with at this point is that you can see all the points plotted in your window. So you should have 7 data points plotted. And like we said before at the very beginning in the first slide, this describes an exponential growth function. So because it looks like a curve going up like this, we know it's not linear because it's got a little bend in the data here. If I drew in my my trend line, I would say it looks something like this. It's not a straight line, it has a little curve or bend in it. So I'm going to go ahead on the next slide and determine what the model or equation is for this exponential growth function. Our next step is to find our exponential growth model. And to do this, we first have to go to stat again. Again, the stat button is right here on the calculator. So there's the stat button. I'm going to press stat. But this time, instead of editing the data, we're going to arrow over and choose the option calc at the very top of your screen, you'll see Edit and then Calc. So use your arrow keypad here to arrow over and select Calc. Now you want to scroll down and select where your exponential regression is. If you scroll down far enough, I think it's option 0, which is really 10, you'll see EXP reg. That stands for exponential regression. And the word regression really is just a fancy statistical name for coming up with an equation for a set of data. So, under exponential regression, once you select exponential regression, depending on the operating system you have to tell the calculator where your data is. And so we're going to say exponential regression, and you have to tell it list 1 and list 2 is where your data is stored. Or if you stored your data in alternate lists, then you have to tell the calculator what list your data is stored in. Now, depending on what operating system you have on the calculator, how old or new your calculator is, you'll see that you can change where your data is stored, or if you have the oldest version, what you'll see is on your calculator screen, you'll see exponential regression, and then you have to tell it list 1, comma, list 2. That's the calculator I have. I have the old version, and so once I select exponential regression, it brings me back to the main screen, and then I need to tell the calculator that my x values are stored in list 1 and list 2. And what you should come up with is a regression equation, an exponential regression equation for your data. Once you find your equation, you'll see your equation in the format of y equals a times b to the x power. And it tells you that the value of a is approximately 399.57 and b is 1.19. Well, I'll say 1.189. You could round that to 1.19. So your model then is going to be written by plugging A in for A and B in for B. So you would get y equals 399.57 times 1.189, or 1.19 if you rounded, to the x power. So on the last slide, we determined that our equation was 399.57 times 1.189 to the x power. And what this is stating is that the bacteria population at time 0 is represented by A, right? At time equals 0, our value in our table was 0,400. Well, if we rounded this A value, we would get 400. So that is the initial amount of bacteria present at the start of the experiment. B, right here, this B value represents our growth rate, which is, in this case, 18.9%. Now, you might be thinking, well, why in the world do we have 1.189 and not 0.189? So, 18.9% as a decimal is 0.189. The reason why we have this 1 here is because we are keeping 100% of our bacteria and increasing it by 18.9%. So my multiplier here has to be 1.189 because really we're growing by 118.9%. Because we're keeping 100%, which 100% as a decimal is equal to 1. So if I want my bacteria to increase by 18.9%, I need to keep 100% of what I had originally and increase that amount by 18.9%, which is 1 plus 0.189, which is how they got the 1.189 here. Now, notice that your correlation coefficient, if you had your diagnostic turned on your calculator, this R value or correlation coefficient tells you the strength of your model. It tells you how accurate it's going to be when you use it to predict into the future or backwards, so outside of the data set. So when you extrapolate, when you go to pick an X value such as X equals 24, which is 24 hours after the start of the experiment, this will tell you the accuracy of your model. Our R value is pretty close to 1, which means that it's almost 100% accurate in determining the number of bacteria at a certain time t. This indicates a close fit to the data, right? So in the Y value, or the Y equals menu, I want you to pick up this regression equation by entering vars, stats, EQ, and regeq. So what I'm basically doing in this set of instructions right here is I want you to go ahead and copy and paste your equation into your equation editor. So by selecting Y equals, make sure you don't have anything entered in Y1. So if you do, clear it out. And then if you go to the vars menu, which is right next to clear, you can choose statistics and then arrow over to EQ. And then option number 1 is regeq. And then you would be able to copy and paste your regression equation into your Y equals. This allows us to graph this math model, this exponential model, over the top of our scatter plot. Once you graph the regression equation over the top of the scatter plot, you will see that it's a very good fit. So that backs up the fact that our R value was like 0.999, or R was approximately 1. What we're saying is that our equation, or our exponential model, is almost a perfect fit to the set of data. You can see that this regression equation or math model goes through almost the center of exactly every point. Not quite. It misses the center of these 2 points right here, but that is why we got an R value close to 1 and not exactly 1. Our next step, or part of the problem, is to use our model to predict what the number of bacteria will be after 24 hours. So going back to our equation, which we have in our equation editor, the next part I would select the calculate menu. We want to calculate the number of bacteria. So since I have my equation already in Y equals and my scatter plot on my graph, I can calculate the number of bacteria after 24 hours. So if I go to this calculate menu right here above the trace button, on option number 2, I would say, or step number 2, I would choose number 1, which is value. Okay, so step 2, after I choose the calc menu and go to calc, option number 1 says value. That should bring us to our graph, and you'll see an X with this blinking cursor right here, right? You'll see an X value, and it'll say, okay, what do you want for the value of X? What we're going to do is plug in, right here, plug in a 24. We want to know at time equals 24, since time was graphed in our x-axis, or into list 1, we want to know what Y is when X is 24. So if you type in 24 here, my guess is that your calculator is going to say invalid. Well, the reason it's saying that X equals 24 is invalid is because our window on our graph is only set up to predict from -1 to +7. This was our x values. That was our x min and x max right here. X minimum and x7 was our maximum. Well, 24 isn't between -1 and 7. So what we're trying to do is predict for x equals 24, which is not part of our window. So if we want to predict at x equals 24, we have to go back and change our window. So if we change our window to be, instead of x minimum, we can leave the x minimum at -1, but we can make our x max like 25 and count and change our scale to count up by 5s. If I go back and follow these steps back to the calculate menu, if I go back to the calc menu and then back to calculate value and then plug in x equals 24, you should get a value of 25,519. Now that is if we used all the decimal places of b. If you rounded your b value to 1.19 instead of 1.18910413335, like we got, if you use all the decimal places of b, this is what you would get. If you chop down your equation, if you rounded either a or b in your equation, you're not going to get exactly this number, which is completely fine because we're using the equation to estimate or predict how many bacteria there will be after 24 hours. So I'm going to be pretty lenient as long as you're in the ballpark of the number of bacteria that I got, and you're not thousands and thousands off, then you don't have to worry about having the exact same answer that I do. Now, if you look at what the calculator did, the authors of the textbook, when they typed in their equation, they rounded their b value to 1.19. And so when they used the calculate feature to calculate the value at x equals 24, notice that because they rounded their equation differently, they got a different number of bacteria than we did. We got 25,000 something, and they got 26,013. So again, just to reiterate what I said on the last slide, I have to, depending on how you round the values in your equation, that's going to affect what you get for your output when you use your equation to predict after time t. So to finalize the answer, what you need in your answer, and we did not get the exact same answer as them, as the textbook, because they rounded their equation differently than we did. We used all the decimal places, whereas they shortened it to the nearest hundredth for the b value. So I'm just showing you this slide to show you what I want in the answer. The question asked us for an exponential regression equation or model, and then use that equation to predict at x or t equals 24. Okay, they used t as their x value and b of t, which is bacteria at time t, and they got 26,013. So again, depending on the rounding, you'll have approximately what they have here. In example 1 guided practice, the number of leaves falling per hour from the trees in an arboretum is shown in the table below. Use an exponential regression model to predict how many leaves will fall in the 10th hour. So in this example, you need to find an exponential regression equation or model for the set of data given to you for the hours and number of leaves, and then use that model to predict how many leaves will fall in the 10th hour. You have 4 choices, A, B, C, and D. When you have completed your work, select your answer and press submit.